critique of what you're seeing here.
You go first.
Turn around and shout it out.
They're not lined up with the channel for the first thing.
I think the head
They're
walls.
cutting into this head wall.
Yeah.
Don't they have to do with the entrance loss coefficients to kind of get a better head wall to get the stream to kind of funnel through the culverts appropriately to go through?
Well,
Also, if you're pouring this much concrete in the first place, you might as well not even use a pipe. You might as well just use
A
You
box
could just do
culvert.
arch bridge or something that would
at
have
which
been.
point you can get it.
Well-
you really can tabletop it and get it very much more natural.
one of the big problems with anything like this, okay, it's a small channel, where you try and get all the flood flows through here. So it's all the flood flows, especially if you have some earth embankments leading to the bridge, because you don't want to be driving through flood water going to your property. Then all the flood flow is channeled through here. Now, unless you have a massive capacity, you're going to get a backwater. As soon as you get a backwater, you get sedimentation. So that gives you an overwide channel off and upstream from it. And then what happens, you got a blasting flow at high velocity with very little sediment just going straight off downstream. And so you then get a scour pool, and often you get a head through it, so you lose continuity for fish and whatever. So it's pretty much a mess.
So would you recommend they have a smaller culvert and maybe 2 low flow culverts on the side?
Oh, y'all love it. What you want to do is to have more than one size fits all the flows. You design your main one for your Bankfull, if you like, and obviously some airspace above. So the Bankfull flow has continuity. Then what you do is you put in some extra culverts, often at a higher elevation, i.e. at Bankfull level, that will drain the overtopping flow that wants to go down the floodplain, because otherwise you have a problem of contraction. So that is one way of doing it. On bigger rivers, and this is what we published with Peggy Johnson, this was funded by your guys, abutment scour. Often you'll have a big single span bridge, no piers in the river, but concrete abutments on either side, and it's probably the same width as a river, but then it's got to accommodate all the contraction flow of the big flood coming through, and as it gets to the river, it puts in a big backhead, doesn't it, with a vertical axis. Those are nasty for scouring, so it can often underpin the abutment wall and you've got problems. So it's a question, how can you counteract that vertical vortex that comes as it spills into the river? So what we did was to put some of Dave's veins, and Peggy didn't do what Dave and I told her to do, because she had a boyfriend who was an aeronautic engineer and he knew better on these things, and he put the veins a bit further upstream. Dave and I would have actually put them onto the bridge abutment. So you start your vein on the bridge abutment and drop it in at your 20 or 30 degrees upstream onto the bed of the river. So when the river's at high flow, that is doing that against that, so it counteracts it, and it really just killed all the scour at bridge piers. And I've seen Dave put a number of these in, similar